Hey everyone, welcome to Terminal Tinkering. I'm Jeff Butts from the Mac Observer, and I've got a special episode in store for you today. What we're going to be doing is we're going to be taking an Arduino board, an Arduino 101, which has Bluetooth, low energy capabilities built into it. We're going to wire that into a temperature sensor, and then we're going to broadcast the temperature readings to my iPhone. So let's dive right in and take a look. Okay, let's build a temperature sensor using Arduino. I've got all the parts that I need right here in front of me. As you can see, not too many for this particular project. I have my Arduino board and a breadboard on my SparkFun Electronics Arduino board base plate. The Arduino 101, which is what I'm using, has built-in Bluetooth LE. Okay, I also have my wires and my temperature sensor. This temperature sensor, this is a tiny guy, so you might not be able to see it. But this is a TMP 36 or TMP 360, I can't remember which. But it's just a tiny temperature sensor, 3 pins that I'll put on my breadboard. Now, the way the TMP 36 is laid out, there's 3 pins, as I said. If you're looking at the flat side of the sensor, the left pin on the TMP36 is the hot, or the plus side of your voltage. The middle pin is the analog voltage out, which goes to my analog input on my Arduino board. And the right pin, again, looking at the flat side of the TMP36 sensor, is the ground, or the negative terminal on your power. So let's go ahead and wire it up. I've got my wires. I think I'm going to start with my negative. I'll go for my negative post on my temperature sensor, and I'll wire that into the ground on my Arduino board. So I'll plug in to the right row for my negative ground, and then I'll go ahead and plug this into the ground port on my Arduino board. Now I'll take my green wire, which I'm using for my sensor pin, which actually sends the reading, and I'll insert that into analog 0 on my Arduino board. And finally, I've got my red wire, which is the positive terminal. Plug that into the positive post of the temperature sensor, and then into the 3.3 volt on the Arduino board. I'm old, I have bad eyes, forgive me for having to look so closely. But there you go. That's the temperature sensor, and it's wired into the Arduino board, and it's ready to send all of the information that we need to check our temperature. So let's switch over to the computer, and we'll program this baby and see how it works. All right, I'm back at my computer now, and what we're going to do now is we're going to actually program the Arduino board to pull a temperature reading and then go ahead and broadcast that over Bluetooth. I'm launching my Arduino software now, and the only thing I don't like about programming for the Arduino is how long the software takes to load. I'm pretty sure this is a Java program, so it has a lot of overhead, and it takes quite some time to load, as you can see. Okay, our software is loaded, and we're good to go. We've got our Arduino app launched, and I've plugged my Arduino board into the USB port on my computer. So now I can start actually programming it. Now you'll see I've already written the program, and this code will be made available to you, so you don't have to worry about trying to write it down based on the tiny screen here. Here's what the program actually does. Okay, CurieBLE.h and CurieIMU.h are libraries that I've included. CurieIMU.h I'll actually take out because I'm no longer using it. I was using it to read the temperature sensor built into the Arduino board, but I decided to switch to an external sensor. I'll leave in QrieBLE.h because that provides my Bluetooth low energy support. And then I've gone on with my programming. The first thing I do is establish what pin I'm using for my temperature sensor, which is analog 0. I just put temperature pin equals 0, and that's set up as an integer. Then I have two floats, temp sensor C and temp sensor F. That's for actually getting the temperature information. BLE peripheral sets up my device as a Bluetooth low energy peripheral. And then I set up my services. I've got my service and my characteristic, as you can see here. These numbers are the UUIDs that I've pulled from Apple specifications. And on my characteristic, I define the UUID, and then I tell what permissions it has, BLE read and BLE notify. Now the BLE read says that devices can read that characteristic from it, and then BLE notify, which sets up the notification service. Previously, I was configuring my app to run a loop, a timed loop, but I've got notification working, and that is a much cleaner way to pull the information that I need. Now we go into the rest of the code. The first thing I do is start the serial console monitoring, and that's so that I can debug the device. QrieIMU.begin, I'm removing. That was from a previous iteration of my prototype. And now I've got my integer reading, which reads the analog port and determines what the temperature setting is. I've got a float called voltage, which reads the voltage from that analog pin and then converts it to something that is almost our temperature reading. There's still more work to be done. We multiplied by 3.3, which is the volts that's being used, and then we divide that value by 1024. I've got my floats to convert my temperature to something readable. One for Celsius, one for Fahrenheit, using the proper formula to convert a centigrade temperature value to Fahrenheit. And then in current temperature, I use a little bit later on just to establish a rounded number that I don't use anywhere other than for evaluation and debugging purposes. I print that information to my console. That way I can see it when I'm prototyping and getting ready to set everything up. As you can see here, I'm printing off various variables along with text so I know what I'm looking at. Now we'll go on to the rest of the code. This is all still in the setup phase. We begin the Bluetooth. We set our device name. We set our local name. And we set what services we're going to advertise. This makes for an easier way to identify the device if you have multiple BLE temperature sensors. Then we add the characteristic with the current temperature. We add the service for the temperature sensor. And we start advertising our Bluetooth low energy services so everyone else knows they can pull information from us. And again, for debugging purposes, I'll just print this on the console. And that's all for the setup loop, or the setup function. Next, we'll have our loop, which basically runs over and over again, as you would think from the name loop. And this is where some of the magic starts to happen. Okay, we start listening for BLE peripherals and centrals to connect to us. If we get a connection, we broadcast that on the serial console. And this I will most likely remove once I'm done prototyping. I'm going to set up a timer. What this does is it makes sure that every so often my Arduino device updates the temperature characteristic. I read my temperature, update it. If we get disconnected, I'll put that on the console as well. And here's my update characteristic, a very simple function that just sets the value of the current temperature. So with that done, I'll compile my software. And if you haven't run the Arduino package in a while, it might take a few extra seconds to compile, but eventually it finishes. And now I'm checking to make sure I'm connected to the right USB port. This is the one frustrating part about programming with Arduino, is the boards sometimes disconnect from USB and you have to reconnect. Sometimes you have to reboot. Here's our serial console. This is where we can see our debugging information. And we'll go ahead and push the new software to the Arduino board. Occasionally, when you've made changes to your software or you're pushing a new piece of software to the board, you may have to push it twice to get it to actually complete running. That is, I don't really know why it happens, but I've seen it on both of my Arduino boards, so it seems like it's pretty common, at least for me. So I'll go ahead and push it again. And it says it's starting the download script. It says the sketch will execute in about 5 seconds. So I look at my console, and there we go. We've got our initial temperature data, and it's listening for BLE. That means we're good to go, and we can start setting this up on the actual iPhone app to read that data. All right, we're back at my computer. This time, we're looking at the code behind this particular iPhone app that I created to talk to my Arduino thermometer. As you see, I've got an app icon called Burns Therm here. It's using the default Apache Cordova icon right now because I haven't gotten around to changing that. But here's what it does. It connects to my Arduino thermometer, reads the temperature, displays it in text down at the bottom, and then it actually demonstrates how that would look on a mercury thermometer. So one of your outdoor thermometers, say I had one in my room, that's what it would look like. And you can see it just updated, and that's what the app does. And we'll look at the code itself. The first thing I want to show you is basically this is what the app screen is made from. It's just a web page. That's what Apache Cordova is all about. It takes your web design. It even supports HTML5, which is how I'm able to do the thermometer easily. It's how I'm able to do the mercury fairly easily. So it sets everything up with HTML. It also incorporates JavaScript, and that's what does the programming behind it. So index.html, all of this translates to the page itself, what you see on the app screen. Now the magic is in the code. In my index.js code, I'll just move things around a little bit, make it a little easier for you to see. The first thing I do is set up my temperature sensor, and I'm telling the app what to look for later on when it's scanning for Bluetooth devices. It establishes the service UUID and the characteristic UUID. The UUIDs are usually unique, but in this case, I'm using Apple's specifications for the service and Apple specifications for a temperature sensor reading. Okay, then we go in and start the app. It begins scanning for a temperature sensor. Until it finds one, found temperature sensor is set to false. As it's scanning, when it finds something that has the temperature sensor, and that's all done here, BLE scan. Okay, BLE.scan starts scanning Bluetooth devices all around. In this case, you notice I have temperature sensor service, and what this means, this is an optional parameter that you can pass to BLE scan. and it tells the function, only tell me about things that have this particular service. It scans for 5 seconds. If it doesn't find something in 5 seconds, it gives up. If it finds something, then it runs on scan. And if the scan fails, it runs scan failure. Back up here in my scan function, we've got a function that when it finds a temperature sensor, it sets that value to true, and then it attempts to connect to it. If it connects, it runs a function called onConnect, and if something happens and it disconnects, then it runs a function called onDisconnect. So let's take a look at the connection. It tells us what we're connected to. It changes initializing at the top of the screen to "we're connected, yay," and then it reads the temperature characteristic for the first time. If I don't do this, then my app will have to wait for 2 to 5 seconds for it to receive a characteristic update. It reads the temperature, it sends the information to the proper function, which is app.onData, and after that runs, then we start our notifications. This establishes a relationship between the server, which is my iPhone, and the peripheral, which is the Arduino temperature sensor. That relationship is one of, if the Arduino temperature sensor registers a change in the temperature, it broadcasts a message to anything that has notifications turned on that says, "Hey, my measurement changed. Do you want to take a look?" In this case, the server, my iPhone, says, "Yes, absolutely, I want to know that." And so it runs onData. It pulls the current temperature into a float 32 array. It manipulates it, rounds it off to a 2-digit, 4-digit actually, 2 decimal points on the value. It pulls the Fahrenheit temperature, and I go ahead and round off the Fahrenheit temperature to a whole number instead of decimal points. I think it just looks cleaner. It's more like you would expect for a Fahrenheit temperature. Then it writes that information, and then the really fun part is it runs draw. Now what draw does is it actually creates that red rectangle that is designed to imitate the mercury of a thermometer. And that's done through a lot of mathematics, several algorithms, and all of this code will be provided to you. So if you want to duplicate this particular prototype, you're more than welcome to. Some of the code I wrote by hand, some of the code I found from other places. All of the code was at least customized to work on the iPhone 7 Plus. So that is the app. So if you have any ideas for additional projects that you'd like to see on terminal tinkering using Arduino, Raspberry Pi, or any other ideas you might have, give me a shout. Send me an email at jeffb@macobserver.com or find me on the Twitterverse as @Clefmeister. So I hope you enjoyed this particular prototype, and I'll definitely be back with more.